Hello, everyone. Hey, as promised, I am back to doing some videos, and I want to talk today specifically about one project coming up, but there's another one that I'll just mention briefly. One of the uh, one of the golf cart battery upgrades that I did um, on the white, I think it was Easy Go. I believe it was an Easy Go. Anyway, that owner would like to build essentially a version of a power wall. In other words, he wants to be able to plug in to his cart to power things like a refrigerator or air conditioner or something that way during power outages and so forth. So that is a project coming up. That's just in the really early stages. I haven't even started buying materials for that yet, but it's coming. So I'll cover that. Today we're going to talk about my current project, which is the building of a portable power station. And this portable power station will involve taking a solar input. So we could call it a solar generator, I guess, if you will. I'm not going to spend a whole lot of time out here in my shop, and here's why. This is 40% humidity, but it's only 101, not quite 102. So a little warm, a little uncomfortable. I'm going to move right along here. The project started trying to figure out. Well, first of all, I purchased a couple of lithium LiPo 4 batteries about 4 months ago to start this project, but life has gotten in the way, and I hadn't really got started on it until now. So recently, Harbor Freight had some deals on various products, and I bought the largest Bauer toolbox that they had available at the time, and thinking it was going to be plenty big enough for my needs. This, this toolbox, as it turns out, is not going to work, and I'll show you why in a little bit. It is 20 and 3/4 wide. It's about 13 and a quarter front to back, and it's about just a little over a foot tall, 12 and it looks like about 12 and a quarter inches tall. That would be okay if I was going with a single battery. However, what I bought were some new to me, and this is all purchased out of pocket. None of this is provided for free. These are Humsync 12-volt 100 amp hour LiPo 4 batteries, 1280 watt hours. These are essentially equivalent to the losages that I've been using in the past. But I've looked at the reviews on these, and they're amazingly well built for what is considered a budget battery. These are very well built and worth trying out. So I have two of these, and once I got the toolbox and set these batteries in here, I learned that by the time I put an inverter in here, I've got no room for a solar charge controller or any of the other cabling and so forth. The cabling for, well, let's just do the inverter that I have opted to use. I'll probably do an independent or another video on each of these components, or maybe a small group of the components. But this was a very well reviewed inverter on Amazon. So it's 1500 watt. It's got a 3000 watt maximum peak power. Pure sine wave. I really like that it has very well insulated battery connection ports on here, so I don't have to worry so much about short circuits. And it does have the 4 AC outlets for house current outlets, but it also has a place where I can hook up a wire directly to it and then put like an outlet or a power strip or something on the outside of whatever case I end up using. It won't be this Bauer. This is just going to be a toolbox. But I do have I do have an enclosure in mind, and I'll cover that in a later video. But anyway, that's why I needed to try this out, and I think I'm going to be happy with it. I've not powered it up and tested it at all yet, but I have watched several videos on it. It does have a remote meter that I will be using, and it's kind of hard to see in here, but this will go to the outside. You can turn the inverter on and off with it. It also keeps track of the power used going out here in the form of house current kind of thing. So I'll have that available. And it does come with its own cables, although I don't think they're heavy duty enough. So, but you can kind of see, I mean, it does fit in there, but there's just no room for anything else in there. So this enclosure is just not going to work. For cabling for 1500 watts, I want to keep it at 12 volts. I'm going to have these two batteries in parallel. So it'll give me 200 amp hours. So that should be more than sufficient to support a 1500 watt pure sine wave inverter. But I do have 2 gauge. This is 2 gauge battery cable that I will be using to run the cabling from the batteries. The batteries go to a plus and minus port, and then go from there to the inverter. And then also the solar charge controller that I put in will be on a 6 gauge cable that will also feed back to the plus and minus bus bar. Some of the other components I've got so far. Well, I do have the connectors for the two gauge wire. So put those on. I do have the main battery switch to turn this on and off with, so I can control safety thing. When it's not in use, I can completely shut it down with this. I do have, well, I had purchased, this is a PZEM061, which monitors AC power, AC current. And this is what I was going to use going from the inverter to whatever it plugs into, power strip or whatever. Turns out I probably won't need this due to the monitor that comes with the inverter, because this does exactly what I need to monitor. So I'll save this for a different project. But I do have the PZEM051. This is the same model, and that if you looked at my solar build 1 and solar build 2 videos, it's the same exact PZEM 051 that I used in that project, which I still have, and I'll be reusing some of those parts on this and another project that's coming up in the future. But anyway, um, I got that to monitor the DC side batteries and solar power coming into it, and that kind of thing. So right now I have a foldable 60-watt solar panel that I have used in the past for my amateur radio stuff to keep my batteries charged up for doing ham radio things. I want to use that for now, but I am in the market for something portable, foldable, and I would like to have at least 200 watts available. So I was doing some shopping today, and I haven't made any decisions yet. And hopefully I'll find something that'll be portable, because this is all going to go on an upcoming camping trip, and I simply won't have room for the full like 100-watt panels that I took last time. There's not going to be room. I'm taking a different vehicle very likely, and um, it's just not going to work out. So if somebody has suggestions on a decent foldable um, set of solar panels, let me know. I'm looking to take at least 200 watts. If I can get 300 or 400, that'd be great. But 200, I think, is what I need for minimum. And I believe that's what I have. Oh, the connection. Let me see. I don't know what I did with it. Yeah, I'll put that up. Apparently, Apparently I didn't get out here with it. Anyway, the connection point, or the connection that I'll be using, this will have 6 gauge. Yeah, I'm doing 6 gauge wire coming in from the solar panels. So that'll be a safety thing there. So anyway, that's what I got for now. And I'm going to get this edited and posted, and then hopefully by a week or so from now, I'll have the other case or the enclosure that I want to use, and maybe some of the cabling done. We'll see. But I'm looking forward to this project. I think this is going to be fun. I'm going to take this instead of that whole setup that I took last time, and it's just going to be the one inverter instead of all three like I took before. And okay, that's it. Thanks for watching.